Hello. I would love to take you on a trip to the Belgian part of the North Sea. The sight of its majestic wind turbines is unmistakable. The numerous cargo ships and fishing boats are equally conspicuous. And yet, you may also be acquainted with the sand mining activities and the secretive maneuvers of military vessels, the civilization of mussels hanging in the sea. Also, let's not forget about the vital tourism and recreational activities. In summary, numerous activities and diverse interests intersect and mutually shape this compact maritime world. Here, amidst the waves, a question surfaces. Are these activities environmentally sustainable? Enter SUMES, a development of a comprehensive methodology that measures the local to global impact of marine activities. What about renewable energy, for instance? One must examine each stage of the value chain to quantify the overall global impacts on the environment and society, commencing with the initial phase, extracting all essential resources, followed by manufacturing intermediate products in various factories. Subsequently, transportation of these products occurs until they reach the offshore site, where installation occurs poised to generate the required electricity. For 25 years, the offshore wind farm will be operational and maintained. Afterwards, we encounter the end-of-life process, dismantling, transportation and treatment, including recycling, incineration or landfill disposal. Identifying the value chain is one thing, but how to measure global impacts? This can be done through a life cycle assessment. At every stage of the value chain, we evaluate the utilization of natural resources and the waste and emissions generated. We quantify both its negative impact, such as contributing to climate change, and its positive impact, like material recycling. To assess impacts comprehensively, one must consider the local impacts across the entire value chain. Let's discuss first the terrestrial processes. They occupy and transform land, and thus change the surrounding ecosystem concerning provisioning, regulation, and cultural ecosystem services. These impacts can either be positive or negative. Quantification of these impacts occurring on land is possible with the help of existing databases, such as the Ecosystem Services Valuation Database. Local impacts at the seaside, however, are measured differently. To identify and measure these local impacts, SUMES builds on an ecological risk assessment and ecosystem services analysis. Firstly, there is the evident generation of electricity. Additionally, fishing grounds are shrinking and moving further away, while shipping routes may extend due to the presence of wind farms. The new environment created by the wind turbines serve as nurseries and habitats for certain young fish species and can alter carbon fluxes in intriguing ways. While CO2 is expected to be released as a result of the installation, the habitat created on the monopiles and jacket foundations absorbs CO2. A thought-provoking phenomenon, isn't it? When gauging cultural impact, consider tourist excursions near the wind farms organized for birdwatching. Every impact, whether positive or negative, holds significance. The SUMES methodology quantifies local to global impacts, both positive and negative, and puts them on one scale, in euros. To allow a comparative analysis, benchmarking with current alternatives is performed. Furthermore, SUMES quantifies the environmental impact of one marine activity or a combination. This empowers policymakers and industry leaders with the opportunity to compare and make well-informed decisions, guiding impactful, sustainable development. The SUMES project involves 4 main partners: Ghent University, University of Antwerp, VLIS, and the Blue Cluster, and gets support from the Industry and Government Advisory Board and from an international scientific expert team.